Alright guys, KK4PY in here again. A quick update on the Pixie project. I repaired my rig blaster. The parts came in. It's the new optocouplers of 4N37. It originally had a CNY17.3 in it. And I got a good deal on these. It says it's pin compatible and same function, etc., etc. So theoretically, it should be working. It shows it's working on the digital multimeter, but I also added a socket so that I can change that out in case I blow this one too, or in case this one just doesn't work. But it looks like it's working. So I lost the interface cable to go from that to the ICOM, so I can't test it on the other digital modes yet, but today's thing is going to be building the keying circuit. There's some transistors to key the Pixie here, since this just doesn't have the current syncing ability, because this radio puts the entire amount of current through the key jack of the entire transmitter. So this just won't do it without some extra components. So that's going to be a project for later today. But what I wanted to look at now was, I actually got my scope hooked up here. BK Precision 1472C, another $30 Hamfest steel. It's only good to 15 megs, but we're dealing with 7 here. So right now I've got a 7.030 crystal in it. And you see I've got this little homemade dummy load here, which is just a BNC connector with some with a 51 ohm resistor. This actually came in the Pixie kit, and with some very poor instructions to use it for testing, but either way, it's a nice beefy 51 ohm resistor. Somewhere I've got a 10 watt like big ceramic case one that I'm going to build a nice dummy load out of, but this came with it, so I figured I'd use it. And you can see I've got the scope probe hooked up here, and the keying circuit right now is just these two wires that come over here and plug into the breadboard. There's an LED to show when it's on, and then I've just got this really cheesy button here that I found. This is a type of button that comes in it came with a Halloween prop where it says "press here to try me," but it's just a micro switch. That's all. But since it already had the connector on it, I just put some pins on it and stuck it in the breadboard. And I've also got hooked up over here the world's worst receiver. Well, that's not fair. It's not the worst receiver. It's just the most unstable. It drifts around a lot. You start on one frequency and it just sits there and drifts and drifts and drifts. And it's the VEC1140 by Vectronics. There's no crystal on it. It uses an NE602. It's just really unstable, but it works. And instead of using the big 1/4-inch phone jack there, I got these little clips, and I got them clipped onto this little speaker here. So what I wanted to do was look at the output of the Pixie on the scope, and you can see my standoffs came in that I ordered. I ordered these you can see that very well. These standoffs, it was like, I don't know, $3 for 20 of them shipped. eBay, of course. So not ideal, but it was the cheapest option, and right now I'm with the cheapest option, so that keeps it up off the surface so it doesn't short out underneath. And we just got it hooked up to a 9-volt battery here, and this 9-volt battery is powering the receiver, because with power supply you just got too much noise. And for an antenna, you can see I just got a alligator clip just laid haphazardly across the bench here like everything else is. So, see what happens. Well, it lights up, so it's definitely transmitting. Yeah. There's the waveform. Actually, doesn't look that bad. Nice and clean. And keep in mind, this is a really old scope that needs to be adjusted, stuff like that. But why can't I hear it? I was hearing it before. Has it already gone out? Oh yeah, yeah, it went out. There we go. What I can do for testing purposes, and like I said, the LED is just simply so I know that it's pushed down here. For testing purposes, we'll take this out, and we're going to spread it across there. Sorry. Sometimes when I look through the camera, I realize that I'm not pointing at what I'm actually shooting. What I was trying to do is short that out. Maybe I gotta flip it around here. Wow. That's what happens when you try and take video and do something at the same time. There we go. Alright, so this is just shorting out the keying circuit, and it's putting the current of the entire radio through this LED and lighting it up. So, wouldn't want to leave it like that for very long, but here's our sine wave. And you can hear that horrible high-pitched tone. I've got the gain on this turned all the way down. There we go. Alright. So, that's the tone from the Pixie. And what we'll do is I'll unplug this, and we're going to slide over here, turn on the 735. Oh, well, listen to that. We've got action on the QRP band. Okay. Well, it looks like today would be a good day for working QRP. 7.030 is one of the QRP watering holes for CW in the 40 meter band. I happen to know that if I tune up here, well, you're not going to hear it over these guys. But I was doing this experiment last night, and I was able to hear the Pixie just transmitting into the dummy load on 031. My VFO is off a little bit, so I got to go to 031.1 or 2, 3 here. Beautiful. Notch filter cleans that right up. Got the preamp off, on. Now, as you can see, still in lower sideband there. We go into CW mode. We find out that he's not. There he is. Down on 7.029. So, that means that here on 31.2, we just got that horrible whine. Ah, you hear that change? There's the Pixie. I don't know if you can hear it on the video. Let me redo this so that I'm... Oh yeah? I don't know if it's... Well, it's off a little bit, but... That's just into a dummy lid. So, lo and behold, the Pixie lives. For some reason, though, the receiver in this is not working anymore. It's I don't know what's going on with it. It's still transmitting, but I can't pick anything up, even hooked up to a good antenna. Now that whine is probably being caused by this radio. No, it's not. Okay. At any rate, that's where we are. The Pixie is out putting a nice clean signal. And you can hear it. I just don't think it's moving the S meter. No. It's not moving the S meter, but you can definitely hear it coming out of that speaker right there. Well, there we go. That part. Now I know the Pixie's out putting a decent signal. I mean, I know it sounded decent, but now we've looked at it on the scope. It's not the cleanest, but it's not bad. And next step is to get it on the air with a good antenna. Yeah, you can see I built an enclosure for it. I have an Altoids tin, fit in there just fine, but didn't work out because I drilled 2 of the holes wrong, and it just didn't work out. So, at any rate, that's where we are with the Pixie project. Got the 7.030 crystal in there. I got my standoffs. So, next step, enclosure. And I guess I need to build a QRP watt meter because I really want to see how much this thing's putting out. I know they say it puts out more on 12 volts, obviously. There's I found an entire blog about it. So we're doing some reading, but that's where we are with the Pixie project. It's still alive and well. I haven't blown it up yet. And if I do, well, $5. So I'd rather not experiment with building a transmitter with something expensive, because then if I do blow it up, you get pretty upset. So I blew up my rig blaster. That was $60 experimenting with it. But I found another circuit that looks really similar to the rig blaster. That's for using AFSK, audio phase shift keying, to on-off keying with the optocoupler, and I'm going to try that straight out of the serial port, or out of the sound card, I mean, with FL Digi. So got a couple little projects today, but we'll keep you updated on the progress, and you'll hear this little beast on the air soon. So stay tuned, there's always more to come. 73 guys.